the eArchiving conformance seal will be a sign of quality of digital archiving, long-term preservation, and data management following standards and best practices of eArchiving. And you see here a pyramid. It's inverse. It shows structural, preservation, descriptive, and linked data aspects of the conformance. And it's inverse because the width somehow represents the complexity of the task. And let me be sincere, we are at the bottom. So we have the tip of the inverse iceberg, okay? So in eArchiving so far, we are caring about the structural requirements, which means we are validating METs. We are looking into the preservation aspects, which means we use premise file, we recommend premise files, but we are still not validating. So validating premise is the next step. So this is also to encourage, because the eArchiving conformance seal means you can acquire this seal. You can get this seal as a sign of quality for your archive or for your solution. And if you do it now, it's still easy. If we are on top of the pyramid, inverse pyramid with the linked data, it will be much more complex to get the conformance seal, because we want to validate different aspects of interoperability. So this means we have structural preservation, descriptive, and linked data aspects of interoperability. And it's according to the community, to discuss with the community and with the development team in eArk to decide what to actually focus on and what interoperability means. For example, if you look into semantic interoperability, this is a matter of discussion and a complex discussion also, because of the variety of metadata that can be used. But it's something that as a vision we look into, and we encourage you to use GitHub. We are transparent, so you see what's happening. You can open issues, you can ask questions. You can certainly also write to the email address of the support team. But certainly in GitHub has the advantage that everything is very transparent, and you see the threads and you can follow discussion also over a longer time, because we all work a bit in an asynchronous manner where sometimes an issue is being dealt with 1 or 2 months later. Yeah? That's a bit sometimes maybe frustrating if you see it's not advancing as fast as you would like it to be. Okay, so this is the vision, that we go up this inverse pyramid. And interoperability means here, if we look into preservation events, that would mean that, for example, you have preservation metadata in METs, and you can see these preservation events in different systems. So if systems rely upon these data and can interpret this data, they can visualize, for example, okay, I have here different representations. So you know, in eArchiving we have these, that we took the concept of representations, because that is what happens if you change data in an information package. You add representations, and you use premise to document what happened. Yeah, which representation was derived from the other one, and what was the action? Why was the action taken? So the whole documentation, and the desire is, by standardizing this, different systems can actually interpret this data and see, okay, there is this representation which was derived from the other one for this and that reason. Yeah, so that we agree upon how to standardize it. We don't agree concretely on the way how it is being done, but you can have several premise files, one individual premise file. So that's an implementation choice that we leave open. But at the end, we want to have events, premise events that we can find. When it comes to descriptive metadata, it's more complex. For example, EAD, and agree on certain metadata fields that need to be filled. So have a common ground to have a descriptive metadata. Let's stop there. Linked data is a very complex topic. So the eArchiving information package, the IP, let's say it's an instance of the CS, the common specification for information packages. You see here that we have kind of an IP by convention. Those familiar with Java programming, they might be familiar with this coding by convention. So this is actually, you have just, everybody could decide where to put things, but there are specific folders where we put specific things, so that it's clear, where do I find the metadata? Where do I find descriptive and preservation metadata? Where do I find the representations? Where do I find specific metadata about the representations? And this is what we define by convention so that it's clearer how the information packages across Europe are defined. So if we look at the classical OAS type definition of a system migration where you want to get your data from one system to the other, you usually would have a DIP export and on the other side a zip export into the other system, which is a bit strange in a sense because the zip and the DIP are both more snapshots in time than packages that really have a life cycle. So in an AIP, in contrast, you should have the documentation of the life cycle, what happened to the archived data over time. Because if you needed to take migration actions, whatever, you added something that allows you to do simulations, whatever, this can be documented in an AIP during the lifetime of the AIP. And that makes a difference here. And conceptually is problematic to use the DIP and the zip as a means to do this export. So the vision here, that it could actually be like this, that you have AIPs and you could put the other system on top of it. Because if the system is able to interpret the AIPs, it could actually treat the AIPs as zips in this sense. So this would here be the vision that, and I say here, the amount of data is growing at a fast pace. So ETL, so that means extraction, transformation, load, things that you would need to do if you do these migrations, will become very expensive in the future because we will have much more data. And that's why leaving the data where it is actually something that should be possible so that you can read the data from the system directly. So when we are talking about the E-ARK AIP, we had discussions with the solution providers. They have their own implementation of the AIP. Let's call it the logical AIP. They can also have, for example, not premise files, but they maybe have a preservation database where they record the preservation events. That's absolutely fine, but we will not validate that. So we will not validate a system that has a logical AIP and then look, okay, what database are you using for the preservation events? No. We are only interested in the things that you have persisted, that you have stored in the package. So this means when you have such a system, you would need to export this AIP so that we can validate it. And when you export it, we expect, as described, if you have a metadata catalog, you need to export the AAD, for example. If you have a preservation database, you need to store the premise files in RDF or XML format. Then here, just to see, put it on a USB stick and hand it over to us. And this is the package, the zip file or tar file that we take and validate. So this is the purpose what we are doing here. It was already mentioned, this hierarchy of specifications, and based on this hierarchy of specifications, we developed the idea of having a hierarchical validation framework. So the hierarchical validation framework, you see here a slight change of how the specifications are organized, because in this diagram, there is a horizontal part for the preservation. It's not a SITS anymore in this sense, because the SITS is a content information type specification and the preservation metadata is not a content type. The preservation metadata is relevant across all packages. It's relevant for all packages. That's why it's here horizontal, and we call it the common specification for preservation. Yeah, with the recommendation to use premise. And there is a common specification for archival, which deals with the metadata, so that you have it relevant for all. And underneath, you have the SITs, which are then for the different content types. Based on this hierarchical validation framework, we have the recommendation of specific formats. This is open. This depends on discussion and input from the community. And on the right side, you see the E-ARK IP corpus. So basically this corpus is taken as the ground truth for the validator because it shows you valid packages and invalid packages, and this is what the validator is being validated against. So this means our vision here, we are still not there, it's the vision to be open. This means we have a commons IP validator in Java, which is used in Rhoda. We have the Python IP validator, which is used in several contexts for demonstration purposes. But you might not be happy with the performance, for example, and say, no, we want our own implementation. And that's actually where we want to be open. That's why we have in the specifications, we will have an open form, how these requirements are formalized together with tests, how these requirements are being tested against the test corpus. And this allows you to create a validator. Let's say a C# validator for LibSafe, for example, whatever, open to other validators, which means that we need some way of validating the validators. And that's a concept that we are working on, so that we can actually also give the conformance for a new validator that comes into the group that is, for example, relevant in a specific context of a repository implementation. So for the conformance seal, we have a set of requirements and it's a short list, and we wanted it to be short, and it actually takes into account that you might not have AIPs, native AIPs, but you have a logical AIP in a repository system and you can export it. So this allows you, and then you validate these exported AIPs. We allow this specifically to have the freedom to implement the AIP how you want. And well, there are some requirements for the zip, requirements for the AIP, and for the DIP is also one requirement. It's a short list. We don't want to overload people with going through big forms and doing things. I think it's doable to do this with a bit of effort to get the seal. There's a process for getting the seal. So you see there's the validation as one step, the self-assessment conformance. This is basically you fill out a form and answer a few questions. And then there is the review, which is that we we look at the form, what you have said about the requirements, and have an interview, a short interview with you, and to learn about your implementation. And finally, it's the European Commission that gives the seal. So the final decision is on the side of the European Commission to grant the seal for conformance. You see that there are green buttons. This reflects what you have on the website. There's a validation service that you can use. It will change over time, take more requirements into account. There is the self-assessment form, which you can download and have a look at to see what is concretely being asked for. And there is the application form for the seal. So this is just going through. I will do this quickly. There's the validation service itself, which is currently hosted at openpreservation.org. There's just the first page of this form, which you need to fill out to do the self-assessment. You fill out the online application for the conformance seal, and hopefully many of you will get the seal granted from the European Commission. And you find the information on the EC's website. So there's on the e-archiving website of the European Commission, you find information. This basically reflected the same in a bit shorter form on the European Commission's website, and linking to a page where we host requirements. Also, there is a bit of answering possible questions that you might have on the process. There's another page here which is called seal.e-ark-foundation.eu. And yeah, so keep in touch. There are many forms. You can start by looking at the eArchiving website. There is a button on the right side for the Conformance Seal. You can write us an email to support@e-ark-foundation.eu. Follow us on X, formerly Twitter, and on LinkedIn. Thank you.